Hello everyone, welcome back. In the last part, we started our discussion with the inverse trigonometric function. Let us continue with that. So in the last class, we learned inverse of a function exists if the function is 1, 1 and onto. Now, if we consider sin x is not an on-1 function, not onto function. Because if you consider function fx is equal to sin x, then f of 0 is equal to sin 0 means 0 and f of pi, that is 180, is equal to 0. So you see, for two different values of x, we are getting the same image. So this is an example of many one function, not an one function. Moving into, now sine varies, range of sine is from -1 to 1. So if you consider the domain as R and codomain as R, so it is neither 1, 1 nor onto. Now, this is a graph of sin x. Graph of sin x. Sin 0, 0. Sin pi, it is 1. Minus sine of minus pi is equal to -1. Sin pi 0, sin 3 pi by 2, -1, 2 pi is equal to 0. Same way with the negative part. That means if you rotate the angle in anti-clockwise sense and clockwise sense from 0 to 2 pi, and the graph will continue in the same pattern. Like this one and here like this one. If we restrict our domain, of sin x, then it will become 1, 1 and onto. Now let us see. If we consider this part, this branch, that is minus pi by 2 to pi by 2. Let us restrict our branch to minus pi by 2 to pi by 2, or pi by 2 to 3 pi by 2. Same way here, minus 3 pi by 2 to minus pi by 2. Then sine will become 1, 1 function and onto function. See, all these are branches of sine, and that will give you the sine inverse of x. Sine inverse of x. And this branch is called as a principal value branch. Principal value branch. Clear? So, to convert a trigonometric function from many 1 to onto, we need to restrict our branch so that the inverse of the function exists. Now let us discuss the domain and range of sine inverse x, cos inverse x and all other trigonometric ratio. I will discuss the entire graph part in a separate episode. Clear? Because we are going to concentrate on inverse trigonometric function. So let us discuss the domain and range of each of the inverse trigonometric function. So now let us discuss domain and range of inverse trigonometric function. Now whatever be the range of trigonometric function that will be the domain of inverse trigonometric function. Inverse trigonometric function. Now just remember the range of trigonometric function. I explain you through a unit circle. This circle, inside the circle or area of this part, that is the shaded region, represent the range of sin x and cos x. So see, in sine inverse they will become the domain, -1 to 1 and -1 to 1. Clear? Outside this region, this is the plane of real number, so r minus open interval -1 to 1 is the range of trigonometric function cosec x and sec x. So now see, in cosec inverse and sec inverse, that range will become the domain. And entire piece of plane, that is the real number, is the range of tan x and cot x. So here it will become the domain of tan inverse and cot inverse. Clear? Moving into this part, that is range. How we are going to remember it? Because sometimes we forgot the range, which is very important while we are going to solve the problem. Now, so for that, I give you a tip. Remember this function in a triplet. Sine inverse, cosec inverse, tan inverse together. Sine inverse, cosec inverse, tan inverse together, and cos inverse, sec inverse and cot inverse together. So cos inverse, sec inverse and cot inverse. Why I am telling you remember these three parts? You see there is a common thing. Minus pi by 2 to pi by 2, minus pi by 2 to pi by 2, minus pi by 2 to pi by 2. If you remember this in a sequence, sine inverse, cosec inverse, tan inverse, so we know minus pi by 2 to pi by 2. Closed, closed, open. Same pattern, you see, closed, closed, open. And it is 0 to pi, 0 to pi, 0 to pi. So 0 to pi. Clear? Now, if you look at the middle term, that is cosec inverse and sec inverse, they are in the middle. Cosec inverse minus 0 because the function is undefined at 0. Sec inverse undefined at pi by 2. So we remember like this: sine inverse, cosec inverse, tan inverse. Minus pi by 2 to pi by 2 closed, minus pi by 2 to pi by 2 closed, minus 0, and then third one is open interval minus pi by 2 to pi by 2. Moving into the next, cos inverse, sec inverse, cot inverse, 0 to pi closed, 0 to pi minus pi by 2, and third one is 0 to pi open. So closed, closed, open, closed, closed, open, minus pi by 2 to pi by 2, minus pi by 2 to minus pi by 2, minus pi by 2 to minus pi by 2. Same here, 0 to pi, 0 to pi, 0 to pi, here 0, here pi by 2. So just you need to make some pattern to remember all those formulas. Clear? So now in the next we are going to discuss some problem. Now let us discuss some problem. Find the principal value of the following. I am taking 4 examples here. Sine inverse of minus 1 by 2, cos inverse of root 3 by 2, tan inverse of minus root 3, cos inverse of minus 1 by 2. The first thing, this term is positive. Now make sure when this is positive, cos inverse of a positive term, we are going to follow the same rule for other inverse trigonometric function. Whether it is cos inverse of root 3 by 2 or sine inverse of root 3 by 2 or tan inverse of root 3 by 3, anything, any inverse trigonometric function is there, we look at this part. Rule will be the same. Now I am considering second one is sine inverse, cos inverse and tan inverse. The way I am going to find out this value, principal value, we are going to follow the same for cosec inverse, cot inverse and sec inverse. Clear? So, while solving the problem, you need to understand how I am going to solve a particular problem. Clear? Now, before I start discussing one by one, let us discuss some basics of trigonometric function. This is the fourth quadrant. All sine, tan and cos. All sine, tan and cos. So you know here all the trigonometric ratios are positive. So here I am writing all t ratios are positive. You know all these things. Here sine positive, that means cosec is also positive. Tan positive means cot is also positive. Cos positive means sec is also positive. Now one thing, just you need to remember, whatever be the magnitude of the angle in the first quadrant, magnitude of any trigonometric value in the first quadrant, function will take the same value in the second, third and fourth quadrant, but their sign will change as per their quadrant. Let me explain you by taking one example. For example, if I take tan of 45 degree, tan of 45 degree is equal to 1. You know this one. Now I will take what I say. Now see, tan 45 degree is equal to 1. Now if I draw an angle, this angle, reflection of this angle in y-axis, so you will get this angle. This is 45 degree. If this is 45 degree, I am telling this line is a reflection of this line, so this will be also 45 degree. That means this angle is 180 degree minus 45 degree. We generally calculate the angle in anti-clockwise sense. So this is 45 degree in clockwise sense. So this will be the angle in anti-clockwise sense, that is 180 degree minus 45 degree. Am I clear? Now, reflection of this line along origin. Okay. So this is a straight line, so 180 degree, and this is 45 degree. So if you measure this angle, so this will be equal to 180 degree plus 45. Clear? Now reflection of this line along x-axis. So you will get this line. So if you measure this angle in clockwise sense, so it will be 45 degree. Clockwise sense means minus 45 degree. And if you measure the same angle in anti-clockwise sense, so this will be 360 minus 45. Am I clear to everyone? Let me recap yet another way. This is the angle 45 degree. So if you consider this as a mirror, so you will get an image here. This is 45 degree, so this part is equal to 45 degree in clockwise sense. So this is actually minus 45 degree. So if you measure this angle, so this will be 180 degree minus 45 degree. Reflection, if you consider the origin as mirror, then you will get the reflection of this 45 degree line along this line. So entire this part is 180 degree and plus 45 this part. So you will get 180 degree plus 45 degree. And reflection of this line along x-axis. So this is 45. So if you calculate in clockwise direction, so this will be minus 45. And if you measure it in anti-clockwise sense, so this will be 160 minus 45. So in all these angles, so this will be equal to 135 degree. This is equal to 225 degree. And this is equal to 315 degree. Now, if you consider the value, so tan 45, tan 135, tan 225, tan 315. This is magnitude wise, it will be same. That is 1, 1, 1 and 1. First quadrant, second quadrant. It is a quadrant of sine and cosec, so it will be minus. Third quadrant, all sine, tan, positive, cos, negative. So that's why what I told you in the first, whatever be the magnitude of any trigonometric angle in the first quadrant, magnitude wise, they will be same in all other quadrant. Their sign will change as per the all sine, tan, cos rule. Clear? Now, if we move into, we make a general rule to solve this problem. Now, if I tell you that principal value generally take the magnitude whichever it is a small. That means principal value will look at the angle which is small in magnitude. So, if we summarize this result, so we can say in the first quadrant, if angle is theta, then the second quadrant we represent the angle as 180 degree minus theta, where the magnitude of any trigonometric angle is same and sign will change accordingly. In the third quadrant it is 180 degree plus theta, and in the fourth quadrant it is 360 degree minus theta or minus theta. See, I am just comparing the result. If we consider 45 degree as theta, So this is 180 degree minus theta, 180 degree plus theta, and 360 degree minus theta. Moving into the inverse part. Now I am going to explain you the rules for the inverse trigonometric function. Now look at this number. If this is positive, all trigonometric functions inverse. If it is positive, your theta belongs to the first quadrant. Clear? That means whenever it is, suppose here it is given as cos inverse of root 3 by 2, it is positive. So your angle always belongs to the first quadrant. So if it is positive, that's why I told you same rule for other trigonometric function, inverse trigonometric function. So if it is positive, your theta always belongs to the first quadrant. Moving into the second quadrant. In second quadrant, sine is positive. So we already discussed all positive will come here. And here cos and tan is negative. In this quadrant, this is a quadrant of tan. So here sine and cos will be negative. This is a quadrant of cos, where cos is positive. So here sine and tan is negative. Now suppose this is cos inverse of minus 1 by 2. Cos will be negative either in the second quadrant or in the third quadrant. Clear? Now tell me, in which case you are getting the angle as minimum, whether in second quadrant or in third quadrant? So obviously we are getting the angle in the less in the second quadrant. So if it is cos inverse of negative, your theta will belongs to the second quadrant. So cos inverse we discussed. Now looking into the sine inverse, this quadrant, here sine and cos is negative. So cos negative we already discussed. Now sine is negative in third quadrant or in fourth quadrant. Now in which case your angle is minimum, third or fourth? You may say this is 180 to 270 or 270 to 360, but you can write this as minus theta. So if sine inverse of negative or tan inverse of negative is given, then your theta will belongs to the fourth quadrant. So either you can write it as minus theta or you can write it as 2 pi minus theta. If it is belongs to the second quadrant, your angle will be 180 degree minus theta. In inverse, you will never get any angle in the third quadrant. So this quadrant is not going to use to find the angle in inverse trigonometric function. Clear? If you understand this topic, then now we are going to discuss the problem. So first let us discuss this question. Cos inverse of root 3 by 2. Just remember the rule. This number is positive. Positive means your theta will belongs to the first quadrant. So root 3 by 2. Find the angle for which cos theta will take the value root 3 by 2. It is cos of 30 degree. Cos 30 is equal to root 3 by 2. Now, we will not write 30 degree. We write it in a radian. That is pi by 6. So, we write cos inverse of cos pi by 6. Cos inverse of positive. So, we write the angle in the first quadrant. So, cos pi by 6. Cos inverse cos is cos inverse of cos theta is equal to theta. So, here we write pi by 6. Clear? Let us take same kind of problem, one more to understand you. Let us discuss these two problems. Cosec inverse of 2, positive, your angle is belongs to the first quadrant. So cosec inverse. Now write down the angle for which cosec theta will attain the value 2. Clear? So cosec pi by 6, sin 30 half, so cosec 30 is equal to 2. So cosec pi by 6, your answer is pi by 6. Positive, your angle belongs to the first quadrant. Sec inverse 2 by 3. So see, 3 by 2 is cos pi by 6. Cos pi by 6 is 3 by 2. So sec pi by 6 is equal to 2 by 3. So we write sec inverse of sec pi by 6. So is equal to pi by 6. Clear? So whenever this angle, this number is positive, you need to concentrate on the angle for which some trigonometric value will attain that value in the first quadrant. So your angle always belongs to the first quadrant. So I hope you understand for the positive, that is for the first quadrant. Now moving into the sine inverse of minus 1 by 2. Now, for your calculation, I suggest you forget this minus sign for the time being. If it is half, that means sine inverse of 1 by 2, then it is positive. So what will be the angle? Sine will take 1 by 2 value when theta is equal to 30 degree, that is pi by 6. So sine pi by 6 is equal to 1 by 2. So this is the angle in the first quadrant, pi by 6. Now sine inverse negative, so it will belongs to, your angle will belongs to the fourth quadrant, just right now I discussed. So in fourth quadrant you can write angle as 2 pi minus theta, or better to write minus theta, because in magnitude wise it minus theta will be less. So minus pi by 6. So sine pi by 6 is equal to 1 by 2. So sine of minus pi by 6 is equal to minus 1 by 2. So in place of sine inverse minus 1 by 2, we write sine of minus pi by 6. So sine inverse sine theta means theta. So minus pi by 6. Clear? Suppose if we take another example like cosec inverse of minus root 2. So root 2. First find out the value of cosec theta, where cosec theta will attain the value root 2. So cosec 45 degree is equal to root 2. So cosec 45 degree, suppose this is the angle of 45 degree means pi by 4. Pi by 4. So minus means cosec, sine, cosec, tan and cot. Your angle belongs to the fourth quadrant. So we write cosec inverse of cosec minus pi by 4. This is equal to minus pi by 4. Clear? So your rule is first look at the magnitude, forgot about the sign, look at the magnitude, find the angle in the first quadrant, and then using either your answer belongs to the first, second quadrant or fourth quadrant. In case of cos, your answer belongs to the second quadrant, and for other, that is sine and tan, your angle belongs to the fourth quadrant. Look at this one, cos inverse of minus 1 by 2. So cos inverse half 1 by 2. Cos 60 is 1 by 2 in the first quadrant. So cos 60 means pi by 3 is 1 by 2. Negative, cos inverse negative means your theta belongs to the second quadrant. In second, if first quadrant is theta, second quadrant is pi minus theta. So that is pi minus pi by 3. That is equal to 2 pi by 3. So you write cos inverse cos 2 pi by 3. So this is cos inverse cos theta means theta. So 2 pi. Clear? So I just recap the thing. In inverse, your third quadrant is not going to use. In case of positive, all the angle belongs to the first quadrant. Cos inverse negative, your angle belongs to the second quadrant. Sine inverse and tan inverse. In case of sine inverse and tan inverse, your angle belongs to the fourth quadrant. So first, take the magnitude part only. Find out the angle for which tan or sine will attain that value in the first quadrant, and then if that will be theta, then in the fourth quadrant minus theta. So we will get the corresponding angle for which sine and tan will take the negative value, and for cos you need to apply pi minus theta to get the value of cos where it attains the negative value. Clear? So practice the sum based on principal value because very important, it will build the concept. In the next part, I am going to discuss the formula and application of formula, and we are going to use very limited formula so that you are comfortable with all those formula. We solve some problem based on formula. Clear? Till then, it's goodbye.